So, thank you for having me. My name is Stefan Killian. I am a cloud architect and product owner for the cloud infrastructure of MN. I will tell you today a little bit about how we manage our cloud infrastructure, how the teams then work together, how we use the cloud, and I will dig a little bit deeper into how we set up and provision new AWS accounts. I'm from Munich. We're building this amazing trucks in Munich, but the world is changing. We need a lot of more software, and therefore that's the reason why I'm here in Lisbon, because the MN management has decided to set up here and start up in Lisbon to deliver new great products in software. Now our team has grown up to 34 employees in the digital hub with 6 agile teams, but the goal is really to go up to 100 employees here in Lisbon, in this great city. And one of the reasons why I'm here is we're building up here also a cloud platform engineering team to enhance the collaboration between the platform and the product teams. So what my talk is about. I will just explain what we want to achieve very briefly. Then I will go deeper in how the teams are set up, how the responsibilities between the platform team and the product teams is. And then afterwards I will dig deeper into how the cloud platform really looks like, what we're providing from a platform. And then the next step is then also to show how we set it up and how we provision new AWS accounts. And at the end I will do a short wrap up with a lesson learned, what we have done so far. So, what do we want to achieve at MN? Our goals is really to do DevOps in a controlled manner. That's maybe sounds a little bit harsh, but it's more like that we want to do DevOps in the right way, that we have defined, because DevOps is more about cultural aspects and we want to share common values. Our values are principle, what we have defined, architectural standards, so that we share a common mindset on the topics, on the architectural and technical topics. And then also to provide a safety guardrail, to have a safety net for our product teams, that if they are developing products in the cloud, that they have a safety net for them. And what we want to achieve is to reduce common efforts. That really means to reduce the overall effort to set up maybe your CI/CD platform itself. So we want to really enhance our developer experience, enhance our software delivery efforts, that the developer can do more and don't have to care about basic infrastructure things or basic platform things. And then we want also to enable our developers, our teams, to really build the best products in AWS what they can. So we offer up onboarding, consultancy, and trainings for them. So that is really what we try to help them out. One other thing is we are building cloud native applications in the cloud. That really means the apps are born in the cloud and then developed and maintained by us at MN Truck and Bus. So that's not that we're doing a lift and shift approach or we want to rebuild all legacy systems in the cloud. No, it's normally about greenfield approaches, what we're going to the cloud. A little side note that applies, of course, not to all MN systems and all MN IT organizations, because we are a big company and we have a lot of on-premise infrastructure also. So we are building cloud native applications, but what does this mean? We have defined 5 principles. The first principle is build cloud serverless, or to do cloud serverless. That really means instead of building your own MongoDB cluster, maintain the MongoDB cluster, use the AWS managed service. Therefore, that also means that we use the DynamoDB instead of managed MongoDB from AWS, because if you're using a more fully managed service or serverless product of AWS, that reduces the operational efforts enormously. The second is everything infrastructure as a code. That really means every infrastructure that we're building should be checked in a source code repository, managed and tracked in a source code repository, and we are using AWS CloudWatch therefore. And then of course we're doing CI/CD. That is a principle from us, but normally do infrastructure CI/CD on software development efforts, but we also want to do, or we're doing on the infrastructure as a code pieces, CI/CD topics. So that is really what we do. And then we are building stateless application because stateless applications can be easier upgraded, and every state should reside in any AWS services. And we try to build 12-factor apps which are following the 12-factor methodology, so that they are easy transferable between stages, for example. And the last principle is grant least privileges. So security is also important, because if you're new to AWS, often you assign too much rights to your applications, and that can be very harmful for your company if you're having more access than needed, or access to another databases or tables. So now I will dig a little bit deeper in how the teams are set up, because here you see a picture of the Formula One pit stop. Therefore, you need to have clear responsibility who is doing what in the cloud infrastructure, because otherwise, if anyone does what they want to do, you're getting lost and you cannot win the race. So how we are organized, we have our platform team, and we have multiple product teams which are working in AWS, and we have defined a shared responsibility model. So that's more or less an informal contract between the both teams, what they can expect from each other and what they're responsible for. Because an AWS account gives you a great power, but a great power comes also with the disadvantages that you are made responsible then afterward for it in production. So that's the reason why we need this shared responsibility model. So what are the teams then really doing? What is the product team's responsibility? They are building their application or their product in the cloud with AWS managed services for API gateways, or managed services for data queuing and persistency, and in a cloud-native approach with containers or function as a services. Of course, they develop the software pieces and deploying the applications via our CI/CD platform. And then it's really about, they build it, they have to run it, and they also have to secure it, because they choose the parts regarding or following our principles to build up their product, and they should really be familiar why and how they're using technology of AWS, and why is this a good fit for them. It's not that they're building something and then they want to throw it over the fence. That is not what we want to do, because they are really into their code, they know what they're doing, and they should design their applications in a self-healing way, consistency way. And then the last piece is also about AWS spend, because you often hear the term that AWS is expensive. Of course, if you do not monitor it, then it's getting very expensive. And only the product team really knows why they're producing costs. For example, we also manage our GitLab infrastructure in AWS. We expected that the backup mechanism do a file rotate, but unfortunately it was not a file rotate. So we had a linear growth of the backup costs, and only we can see this, that is a failure, which is not that expected, or should not work as expected. And therefore also the product team only needs really to have the eyes on the cloud costs, because they are knowing what they are building, what they want to try to achieve. Exactly. And then we have our cloud platform engineering team. We are providing our platforms as a product, so really in an agile mind fashion. We have a backlog. We really want to evolve our platforms in the future. It's not we build it once and then it's never touched. and we're providing AWS infrastructure, and the second part is also our CI/CD platform, which is mainly built on the GitLab CI, JFrog, Artifactory, and SonarQube. That is the 3 tools which we are providing to all our developers. What we also do, if to enable our developers to give them a bootstrap, it's really we are more or less the maintainer of a set of infrastructure as a code templates, which then can be used by the developer to have a self-service environment to deploy them by their own. Of course, they should then track this also in the source code repository in their own. And what we also defined is blueprints, so how applications should look like in AWS. If you build containerized microservice, how do you deploy this to AWS? And then our cloud platform engineering team offers onboarding support. If there's a new team to AWS, we really have to bootstrap them, support them, or if they have a significant change which they want to do, then we can help them and give them advice. And we really, that's part also of the enablement, that the product team is not alone, that we help them out if they need help, or they have maybe a common or a more specific domain where they're not that familiar with, so that we can help them out and train them a little bit. What we also offer them is architectural reviews. That really means in a regular basis we go in and look what they built and check what is happening there, if everything works as expected, or if they go to a new production go lives, then we also want to help them that they have set it up also their monitoring pieces and observability pieces, because of course they're responsible for the operations, so they need to set up proper observability metrics. What we also do is we organize community events for collaborating, contributing to the same standards. So it's really about get the people together, share information, because things are evolving, so you need to share this often and again, because the platform is evolving. So how is the collaboration between the both teams? What we really try to do is to do this in an inner sourcing way. Inner sourcing is just a term of open source, but just in the company itself. That really means we share the code, and if they have an issue with the code, they can open an issue directly in our GitLab. If they want to enhance the feature because they see there's something missing, they can open a merge request or pull request to enhance these features or enhance these templates. So, and this is really, we also encourage our product teams that they are really contributing to the same standards, so that every product team, or if a product team has a new idea, other product teams can also participate from them. As I already told, we're doing community events, and we're using Microsoft Teams, which is the Microsoft Slack variant. So now a little bit deeper on the platform itself. And you see here an icy road through icy hills. That is really what we want to provide. Is we have the golden path through the hills on a nice maintained road. So we want to provide the golden path for our developers. So from the blueprints, for example, and also for the platform itself. What does this mean? What we are providing from the platform team is we are in charge of the accounts for platform management. That means we own the account for the master account where we do the consolidated billing. We have audit accounts set it up where we collect a lot of security relevant information. We have one centralized IAM pool to have all personalized user access in there. And we are providing shared services like connectivity to our on-premise world via Direct Connect, or setting up DNS resolution for connecting to resolve on-premise systems. And also the same for DNS resolution for public hosted zones. What the product teams get is they can decide if they want to build 1, 2, 3 stages or even more. So that is really, we give them one AWS account per stage. that they can build up their whole pipeline and environments. What they also get from us is a Sandbox account for experiments, because if you're doing new things in AWS, maybe your AWS account gets dirty. It is hard to clean up, and the Sandbox can really easily reset it and restart it from ground up. And normally the production or the stages accounts are really then only infrastructure as a code. And in the Sandbox, it's really you can play around, use the GUI to test out new AWS features. What we also then provide is an additional management account or orchestration account where the CI/CD GitLab runner is deployed to, and then we can do cross-account deployments to the different stages. So we have therefore examples how this works, because sometimes cross-account deployments within AWS are a little bit complicated with the IAM policies and so on. So that is really that we are providing this kind of example. And then the last piece is what happening in this AWS account. That is really, there also the product teams are not alone. We want to provide this common blueprints for runtime for containerized microservices or serverless applications, which is more like function as a services environment. That is exactly, no, that is not exactly, that's our responsibility. Just in a nice looking architectural drawing. On the left side, we see our corporate on-premise network, on the right side, the internet, and then our development teams or product teams getting an AWS account, and we provide some services around this AWS accounts. We're collecting the security relevant information in a central auditor account, for example. We're deploying IAM roles. We have the connectivity to the on-premise world, so that is really what we are taking care of. Then the question is what the product team is responsible for. That's quite easy. They really own their own account. They're responsible for what they're doing in this account. But as I already told, they are not alone. We provide blueprints, and that is one example blueprint which we provide the developer teams to really deploy containerized application to AWS. We are using Elastic Container Services. It's just the container orchestrator by AWS, because there you have, if you follow the principle serverless first, it's more or less, there's no operational efforts to maintain ECS. And in addition, we are using Fargate. Fargate abstracts you the compute node under the container away. That really means you do not have to provision container nodes, compute nodes where you can run on your containers, so you don't have to patch the underlying infrastructure. That is really a big benefit. So with this whole scenarios, we really reduce the operational efforts for our product team, that they can really own the whole infrastructure in this AWS account also, because we're using that much services which is maybe more or less the whole infrastructure is abstracted from you. So that is really a big benefit in AWS. So that is an assembly line in Nuremberg, where we assemble the engines for our trucks and buses. And that is really how we provision our AWS accounts, and how we already also set it up that we have this environment where we can do this. What we do is we automate everything in Python. We use AWS Organizations, which enables you to have this multi-account setup. We're using organizational units to structure our AWS accounts, and we apply different service control policies to these organizational units. That really means service control policies are IAM policy on steroids, where you can apply to multiple accounts. And that is one example of a service control policy, which is defined that only our automation roles have access to change our governance Cloudformation stacks. So the normal product team has full admin access to their accounts, but they cannot remove any security guardrails. That is really the case here. Exactly, we're collecting cloud audit logs. Every call that you're doing against the API of AWS, we are collecting this via Cloudtrail. We have set up additional config rules to provide more security and guardrails features. And then we have built our own account vending machine to create and update AWS accounts. So there we use step functions, Lambdas, and Cloudformation. And I will show you now how this looks like, the combination. That is more or less a step function with a different set of Lambdas and Cloudformation stacks which we're performing. If you issue or if you start the step function for provisioning a new AWS account, the first step is to create a new AWS account via the master account. We are assuming the role, and then we are going in the state machine. We are collecting once every setting which should be deployed. That is an extra table in a DynamoDB, and then we're going through a state machine to iterate each of these steps to configure this AWS account. And therefore we're configuring AM account information, we are setting up governance features, we are doing security guardrails. So that is all what we do in this new AWS account. But that is all about general tasks which we apply to all AWS accounts. And that is more or less our state machine in step functions. So if we have this list on to-dos to work, then we iterate over and over until every task is done in our state machine. And if you only want to configure the accounts and do not want to create a new account, then we only trigger the configure pipeline, also just this step function or this iteration loop without create a new account. So we can easily update existing accounts. Then we have this more specific variants because every product team gets their own accounts, and even accounts in different stages looks different. So for example, AWS budgets, we're setting up a budget limit or budget threshold notification. In your non-productive accounts, maybe the budget limit is 1,000 euros, and in your production accounts, because you scale a little bit higher and wider, it's then 10,000 euros. And also to set up DNS delegation for the private hosted zone to have a nice looking domain name that is unique to the accounts. VPC and networking is unique to the account. This is really what we are currently working on to provide them more benefits for our product teams. So then is the question how we use in this whole setup continuous integration, continuous deployment. We are really dogfooding our own GitLab platform, but we are currently just focusing on CI and source code quality checks because we have some security restrictions because the automation roles are very powerful and have access to all AWS accounts, and therefore we would like to avoid to directly deploy a new version of a Lambda which then can remove every guardrail or create new AWS users in this account. So that is some kind of security restriction which we set up for ourselves. But we try to find workarounds for it. So we are maybe deploying new Lambda versions without pointing the alias to the newest version, so that we can deploy new Lambdas without directly enable them. Or we're doing a nightly job just to check if the deployed service control policy is aligned with what is checked in the source code repository. That is maybe some workarounds which we are looking for. So now I'm on the end of my presentation. So a little wrap up. One point is really we need to improve our CI/CD for our account automation. The next thing is product teams, because they really have or are touching a lot AWS infrastructure, so they really need experience in the cloud. So training and enablement is very important, because otherwise they're getting lost and frustrated, maybe. And then what we also identified is sharing information is not easy. just how we define the blueprint should look like, how the usage of a blueprint or templates is done, because you have a different view on the topics as a product team or maybe less experienced people. That is really not easy. And also to get information from the product teams, the developer, what they really want to do and what they need. It's also very hard to get this information. And then my abstract to leave you, it's really treat your platform as a product, because a great platform can really enhance the software delivery process and reduce common efforts. So not every team needs to set up their own Jenkins cluster just for doing CI/CD, for example. And it's really about to onboard new teams to the cloud. So that was my presentation. Thank you.
Any questions? We have time for 2 questions. The other ones can be made after.
Yes, I got a question. One of the things that we address in our company is that giving too much power to the team could bring security issues and other unregulated stuff. Too much experiment, too much things out of ordinary. And with 40 products, 50 products, things can go out of hand. And if a team goes away and another team needs to pick up the job, it's very difficult to bring up to speed. Do you have that thought that you mentioned the security issues? You set a policy and those are well defined and the team cannot change. Do you have other concerns around it? Things, or you don't care what the team really does inside?
No, exactly. In this architectural review, you will find new things which can go in the wrong way. You always have to evolve, to iterate, and really to adjust your whole guardrails, because some people are very creative to go around, and then you have to find this and set up proper things. But it's not about to restrict people, so it's really more. What I think it's more important to educate them, to help them to understand what is behind there, because that is also what I mentioned about information sharing. It's not easy because we set it up, security guardrails, because they are needed. It's not you should build something around it or just And that is the hard part, to really enable and educate the people.
It's hard to scale that way, right? Because if you have 50 people and for each team. Oh, yes, 50 teams, and for each team you need to educate them. It's hard to scale. Do you have that problem?
Currently, we not have that many teams in AWS. It's just a bunch. That's currently not an issue, but maybe we'll see this in future.
If you've been using your AWS account for any lift and shifts, is there any plan to develop? Because that will limit the ability of you to get old legacy apps into
No, that is really
business critical apps.
There is business critical apps. Currently, we're building one application which is which is needed for the communication between the trucks to enable the truck driver to buy new feature over the air. That is business critical, because if they want to build or they want to have a new feature like assistant system in their cars, then that is maybe crucial for them. So, but currently we are not doing lift and shift programs, because we have also our big data, our on-premise data center, which will stay, and we really want to go only with cloud native application to the cloud. That is really what we are doing.
What about the federation? Do you do any of that for the users? Or?
No, not yet, because it's not working that as we expected. We are really setting up each of the user itself in AWS on a centralized account. But what we're currently thinking about is to write a Lambda function to check if this user exists in the Active Directory in our on-premise world, so that we have this cross-reference anyhow there, but you have your own credentials without federated identities.
Just one more question. question. I saw there in the diagram, at one point you were fronting, one of the proposed diagrams were something like fronting your network load balancer with the API gateway from Amazon. That is to protect the API at the infrastructure at the perimeter with Amazon, or is there something more complex there? It seems like overkill technically. It's like you're doubling your costs with that thing.
I'm not aware that it would be possible without a load balancer in front of your containers. So you
can use the application load balancer from Amazon. It does exactly that part.
But at least in the past, I'm not sure if, because AWS also announces feature, but in the past, at least for a half year or something, it was not doable that you point your API gateway directly to the ALB, only to the NLB.
Yeah, I guess my question was more like you can directly expose the application load balancer to the web. You don't need the API gateway in particular.
No, the thing is about to have more security granular features to do. We're using API authorization mechanism. That is what the keyword why we're using API gateways instead of directly. But what we want to, or what the reason behind it is, no service should be directly exposed to the internet. The first line of defense should be always some kind of AWS feature, so like an API gateway. So because if you're doing or you're offering your Java application directly to the internet, then it's directly vulnerable. If you have an API gateway, you maybe have less things which came through.